An electric heating coil of resistance R is immersed in 1 kilogram of water at 20 degrees Celsius. The coil is connected in series with a resistor Y across a 240 volt main supply. The water boils in 10 minutes. When Y is disconnected, the water boils in 6 minutes. Neglecting heat loss, calculate the resistance Ry of Y. Take the specific heat capacity of water to be 4,200 joules per kilogram per Kelvin. Now, to solve this, the first thing we have to do is look at the data given to us in the question. Now, the first thing we can find here is the mass of water. Let's take that to be m, and that was 1 kilogram. The next one is the initial temperature, which is let's take that to be T1, which is 20 degrees Celsius. Now, the question mentioned that the water boils in 10 minutes. And at what temperature does water boils? It boils at 100 degrees Celsius. So the final temperature is 100 degrees Celsius. Now we're given the voltage supply. So we have our voltage supply, and that was giving us 240 volts. Now, the question mentioned that when Y was in the system, the time it took for the water to boil was 10 minutes. So let me say time, let me say with Y, let me put with Y. That means when Y was in the system, let me call that T1, and that was 10 minutes. And then time without Y, when Y was removed, let me call that T2, and that was 6 minutes. Now, we have to be careful here. We are not going to use the minutes in our calculation, but we have to convert these into seconds. So my T1, let me do that here. My T1 will now become, sorry, T1, not Ti, T1 will be 600 seconds. If you convert 10 minutes to seconds, that's 600 seconds. And my T2 is 360 seconds. Now, another most important one is we have initial temperature and final temperature. We have to find the change in temperature. Change in temperature, which is our delta T. That will be 100 degrees Celsius minus 20 degrees Celsius. That will be 80 degrees Celsius. So basically, we've not done anything. These are just information given in the question. Now, the next thing is we are going to look at what the question is asking us to find. The question said we should find the resistance Ry of the resistor Y. Now we are looking for resistance. We've been given voltage, and the whole question is about energy, electrical energy being dissipated as heat energy, and all this is done with respect to time. And anytime we are talking about energy and time, we are talking about power. And then the only formula we can have that relates these two is power being equal to the square of the voltage divided by the resistance. This means that I can have a formula for my resistance. So if I have this formula R being equal to the square of the voltage supply divided by power, I can get the resistance I've been asked to find. But then the problem here is the question is in two folds, as I mentioned, when Y was in the system and when Y was not in the system. Since I have used T1 for when Y was in the system and T2 for when Y was not in the system, anytime I see 1, let me stick to 1 as in the system, when Y was in the system, and then 2 as when Y was not in the system. Now, in the question, when Y was in the system, the resistance and the power is different from the resistance and the power when Y was not in the system. Therefore, to find the resistance Ry, we need to find the resistance when Y was in the system minus the resistance when Y was not in the system. I've already mentioned about this 1 and 2. Okay, so with the formula already obtained here, I can rewrite my formula Ry. Can write my formula Ry as V squared over P1 minus V squared over P2. That is the power when Y was in the system and the power when Y is not in the system. So basically this formula will take us right into the answer. So the problem now is to find the power when Y was in the system and the power when Y is not in the system. And this takes us to the second part of the question. This is just manipulations. Now, let's find the powers. From the conservation of energy, energy loss is equal to energy gain by the system. Now we have the coil that was losing energy here, and then we have water that was gaining energy. So basically I can write QC, let me say QC as the energy lost by the coil, and then W as energy lost by, energy gain by the water. Now electrical energy, the formula for electrical energy is power times time. Therefore, this electrical energy is dissipated as heat, the quantity of heat here. So I can say that the quantity of heat produced or lost by the coil is equal to power multiplied by time. Likewise, the quantity of heat gained by water is given as the mass times the specific heat capacity of water times the change in temperature. Now, since we are saying they are equal here, it means that I can equate this and that. Therefore, my PT is equal to MC delta T. The next thing is to make P the subject, to make power the subject. So making power the subject, I have my P to be equal to MC delta T, all divided by time. Now at this point, we can find our P1. P1, that is the power when Y is in the system. That would give us MC delta T, all divided by the time when 1 was in the system, that is T1. Likewise, we can find our P2, which is equal to MC delta T, all divided by T2, that is the time when Y was not in the system. So let's find these two. basically our job is done. So to calculate the P1, we have P1 to be equal to 1 times 4,200 times our change in temperature was 80 degrees Celsius, all divided by our T1, and our T1 was T1 that was 600 seconds. And this, my calculator says it's equal to my T1, that's 560 watts. Okay, so my P2 will also be equal to the mass times the specific heat capacity times the change in temperature, all divided by the second time, that's T2, and the T2 was 360 seconds, so 360 seconds, and this, my calculator says, is equal to 933.3 watts. So we have the two powers, P1 and P2, which we are seeking to find. All we need to do now is to substitute them in the formula that we derived up there. Now let me just rewrite the formula here. We had this formula, Ry equals to the square of the voltage supply over P1 minus the square of the voltage supply over P2. Whatever is left for us to do is just substitution. The voltage supply was 240, and then I square it, all divided by my P1, which is at 560 watts, minus 240 squared divided by 933.3 watts. Now this, my calculator tells me that it is equal to 41.14 ohms. So my Ry is equal to 41.14 ohms. Now this is our final answer. If you have any question, you can drop it in the comment section and then I'll attend to it. I'm dedicating this channel to the final year students who are sitting for mathematics and physics. Drop your questions in the comment section and I'll make time to solve all your questions for you. But before that, you need to subscribe, like, and share with your friends and family. Hit the notification button so that anytime I drop a video, you will be the first to have access to it. Thank you for your time. Bye.